So in this video, I selected a couple of the homework problems that I thought I would walk through. So the first one I chose was number 6. So don't be nervous if the equation is in terms of something other than x or other than t. So as long as your function tells you what it's in respect to, so in this case it's in respect to theta, we can go ahead and continue to find that derivative. I just need to do some manipulation of h before I do so. So h of theta is equal to, like, we have a little exponent of 1 here, so when I distribute this in, remember when we multiply powers with the same base, we add their exponents. So theta to the first power times theta to the negative 1/2 is going to be theta to the 1/2 power, because 1 plus a negative 1/2 gives me 1/2. And then, of course, 1 plus this negative 2 is going to be negative 1, so minus theta to the negative 1 power. So now that I've distributed that theta in, I can go ahead and take the derivative. The derivative of h with respect to theta is going to be, using power rule, 1/2 theta power down. So this is going to be a minus 1/2 again, because we are subtracting 1 here. 1/2 minus 1 is negative 1/2, plus, because we're taking this negative 1 and multiplying it by the negative that's already out there, theta, and then we are powering down. So you're done here. I might go ahead and take it a step further and say something like 1/2, let me actually fix that, theta to the 1/2, right? Make this negative power positive by bringing that back down into the denominator, and same thing for our last term, 1 over theta squared. So to me, this would be, I guess technically, you could go ahead and put this back into the square root, so 1/2 the square root of theta, because of that 1/2 power, but I'm fine stopping there. So alternatively, I guess we could have the derivative be this. The next one, h of x, is equal to ax plus b over c. So remember, in the directions, a, b, and c, these are all constants. So these are all some number. We don't know what that number is, but they are numbers. And so we need to think of it that way when we're taking the derivative. Just for structure, right, to get my mind right before I take this derivative, I might rewrite h of x and realize that I am dividing by c to both parts. Now, the first term, if I have the derivative of ax over c, remember, the a divided by c is just a number. So this has an exponent of 1. So when I go and take the power rule, 1 gets multiplied out in front, and then I power down by 1, which would give me 0. So the derivative of h of x, let me actually put this in green. The derivative of h of x is going to be a over c. Remember, that's going to be x to the 0 power. Anything to the 0 power is just 1. So it's just the ratio of a over c. Think about it this way. If we were to take the derivative of, like 2x, the derivative of 2x would just be that constant 2. So just because we don't know that constant, we can leave that in terms of a over c, whatever those variable parts are. And then this is the derivative of a constant. And remember, derivative is just the change or slope. And so if we're talking about the change of something that's constant, that change is nothing. And so the derivative of a constant is always going to be 0. You can put plus 0, but there's no need to. So your final answer is just going to be a over c. Let's look at the next one I have for us. Number 11. So w is equal to 3ab squared times q. So again, in the directions, a, b are constants, meaning that this equation is in terms of w and q. So we're taking the derivative of w with respect to q. So this is just going to be my constant, sum product of 3a and b squared. Similar to what we had just talked about here, right? The derivative of 2x is just 2, it's just that coefficient because of this power of 1. This q also has a power of 1. So when I apply power rule and I multiply that out in front, it's 1 times all of that other stuff, leaving me with 3ab squared. And then I'm going to go ahead and power down. 1 minus 1 is 0. Q to the 0 power is just 1. So anything times 1 is just itself. Okay. Next one, p. I might rewrite p as a plus b t to the 1/2. Remember, a and b are constants. So when I go and take the derivative of p with respect to t, right? P and t are my variables here. A and b are my constants. The derivative of a constant, is just going to be 0. And the derivative of b times t to the 1/2 is going to be 1/2 b t to the negative 1/2. To make that power not be negative, I'm going to go ahead and drop that down into the denominator. Let me be clear here. This 1/2 times b is the same thing as saying b over 2. And then this can be dropped into the denominator. So this would be t to the 1/2 to get rid of that negative sign in the exponent. And then I can rewrite that as the square root of t as my final answer.